Of all the surface of the earth, 7/10 is covered by the sea. If the land sank into the oceans, the sea would cover the entire world over 2,000 meters deep. Long ago, life began in the sea, and much of the world's life is still to be found there. As well as this abundance of life, each liter of seawater contains more than 3 grams of various salts. Near the edge of the continents, the seabed is shallow. Farther out, it drops away steeply to the ocean depths. Most of the sea is nearly 4,000 meters deep and quite dark. Much of the life is in the top 30 meters or so, the thin sheet of surface water lit by the sun during the day. A fine conical net drawn very slowly behind a boat collects some of this sea life. Most of this life is very small, and a microscope is needed to see it well. This is plankton, a tiny form of life which swims poorly, floating and drifting in the surface layers. The plants and animals of the plankton are food for one another, and they in turn become the food of many other forms of sea life. Between the sea and the land is the shore, the narrow strips where the two worlds meet. The nature of the shoreline varies. In many places, the shore is sandy. In warmer regions, mudflats line the shore, and mangroves often grow there. And along many coasts, the shore is rocky, particularly in cooler climates. This shoreline is of great interest. The life of the rocky shore faces special problems of survival in its unusual surroundings. Twice each day, the region between high tide mark and low tide mark is exposed. Twice each day, it is covered by sea. For half the day, it is exposed to the air, to the sun, and the weather of a land habitat. For the other half of the day, it is part of the sea. The degree of tidal rise and fall changes too, from week to week and from season to season. In rough weather, waves batter the rocks. On many such coasts, a rock platform is formed, with crevices and rocky pools. Waves carry plankton there from the open sea. In heavy seas, their crushed remains help form a froth on the water. During the day, the rock platform shows a variety of rock surfaces, crevices, and rock pools. There are organisms in the rock crevices and in the open. Rock pools display abundant life. molluscs like a cowrie, a rose petal shell and a limpet. Sea anemones. Many organisms live on rocks where waves wash them much of the time. Different organisms in different places. About the low tide mark and below it, rarely exposed long enough to dry out, grow some of the larger plants of the seashore, the brown algae. This one is a kelp. A holdfast attaches it firmly to rock. Its fronds are leathery and hard to damage. Amongst green algae near the low tide mark, animals like the congervoy attach themselves. They're exposed for only a few hours a day and are constantly washed by waves. Congervoy is a sea squirt. They start life swimming at sea, then settle down on a rock surface. The rounded shape helps withstand the waves. Sea anemones have tentacles with stinging cells capable of paralyzing prey. Sponges are perforated by pores through which water passes, carrying the small food particles on which the sponge feeds. Various red algae grow about mid-tide level. Some are uncovered for nearly half the day. Their bodies are firmly cemented to the rock and stiffened with calcium carbonate. Growing a little higher on the rocks than many other algae and exposed for more than half the day is another brown algae, Hormosyra, the sea grapes. At low tide on a warm day, part of its life cycle is visible. Male plants exude sperm from pores in their surface. When water washes over the plant, the sperm breaks from the sheath which surrounds them and swim freely. Magnified 2,000 diameters, we can see the two flagella which, by their thrashing movements, carry the sperm to the eggs. Here the female plant is releasing eggs. Each is enclosed in a sac which breaks open to release the egg when water again washes over the plant. The egg visible here is magnified 200 times. Sperm are attracted to each egg and swarm around it. As soon as one sperm penetrates the egg to begin a new Hormosyra plant, a wall forms around the egg. No further sperm can enter. Growth begins in 2 hours. By 24 hours, it consists of several cells. Attaching itself to the rock's surface, it grows into a new Hormosyra. At about the same level as Hormosyra, and also exposed for more than half of each day, are whitish, limy masses made by tube worms. At low tide, each worm withdraws well within the hard casing, where it's protected from direct sun and from abrasion. But once the tide comes in, their long, feathery tentacles wave in the water, trapping small food particles, including plankton, and providing the worm with oxygen. There are many molluscs between the tide marks, browsing on the minute algae which encrust the moister rocks and the weed surfaces in the rock pools. Molluscs on bare rock are exposed to high temperatures on some days and low temperatures on a cold winter's morning. Instead of the salt seawater, rain may douse them with fresh water. In some places, high amongst the rocks, water evaporates and salt is deposited. Few living things have such a changeable living place, and survival is difficult. Higher on the rocks, exposed for most of the day, are barnacles. Like the sea squirts, these begin life free swimming in the plankton. At a later stage, they settle on rock, attach themselves firmly and develop hard, limy plates around their bodies. The opening at the top stays shut, except when the tide comes in. Then their highly modified legs are used to catch the animals of the plankton on which they feed. Still higher on the rocks, reached on most days only by spray and by waves during a storm, are small snails. Periwinkles and other small molluscs depend on minute algal growth for food. So do the tiny noddy shells of the little rock crevices. The rock pool is a rather different living place. The algae and snails are always covered by water, which becomes both warmer and colder than the sea. During the day, little activity is visible, except for perhaps an occasional brittle star. Many animals are seen only when they move. Some crabs can extend and retract their eyes. The crab's hard surface often provides a sight for another animal. Sea urchins can be found in pools and under ledges farther out. They have a mouth underneath and feed by browsing on algae close to the rock surface. Often there are octopus in pool crevices and under ledges. Night is the best time to visit the rocky shore. It's then that it comes to life. Octopus emerge to feed on crabs. Snails graze in the sheltering darkness, exposing the soft foot, tentacles, eyes, and mantle as they move. Powerful eyes probe the dim world. Starfish are predatory, feeding mainly on molluscs. Tube feet emerge from under the body. They act as suction cups. Some hold the starfish to the rock. Others hold the snail and force it upside down. The starfish protrudes its stomach into the shell of its prey and digests it. Eventually it withdraws, leaving behind an empty shell. This is a pistol prawn. The clicking sound you hear is made with the claw and dominates the underwater atmosphere. In shallow water, there are soft corals. A sea urchin. A sea anemone. A scallop. A hydroid. A brittle star. Hermit crabs. Another brittle star. Another tube worm in its tube. A feather duster worm. If we speed up the action a little, sea anemone and sea squirt activity is easier to see. Sea squirts feed on plankton, drawing the animals in and sieving them from the water. The flatworm searches for food, small animals and the remains of dead sea creatures. The rocky shore is a place of continual change and eternal compromise for living things, one of the most difficult of all environments. Yet its life is abundant and thriving, its creatures fascinating and varied, each of them eminently suited to a world which is neither land nor sea.